Hey guys, welcome. 3.6 video coming at you. Here we go. Compound inequalities. What's our objective today? Our objective is to solve and graph inequalities containing the word and to solve and graph inequalities containing the word or. So we have two different types of things going on. You're going to see me do this a lot in class. And or, just like that. Okay, going outward, going inward. And or, and or, and or, and. Okay. What the heck does that mean? Let's talk about it. Here we go. Okay, so a couple things to write down. Let's move down just slightly more. Right there, perfect. Okay. Number one, write this down first thing. A compound inequality consists of two distinct inequalities joined by the word and or. Yes. Okay, write that down. Next, write the essential understanding. You find the solutions of compound inequality either by identifying the solution set of the distinct inequalities, meaning basically where they overlap, or by combining the solutions to set a form of a larger solution set. So this is the word and, which infers overlap. And overlap. See how my hands are overlapping. Okay? So we look at the two inequalities. X is greater than 3. So if we come down here, I have my pencil upside down. X is greater than or equal to 3. It's going that way. 7 is less than or equal to, X is less than or equal to 7 this way. Where they overlap, that is the and portion. Okay? So I'd like you to go ahead and write all of this down and all of this down. Okay, so a lot to write today. Okay? The graph of a compound inequality with the word or contains each graph. Or this one and this one contains each graph. So we have two different graphs and they're going in different directions. Okay? So negative 2 is less than, 1 is greater than, so you include each graph. Okay? Let's go ahead and look at some examples. Okay, number 1. What compound inequality represents the phrase all real numbers that are greater than or equal to negative 4 and less than 6? Okay, so first of all, we have this greater than or equal to, and we have a less than. All right, so all numbers, so that's representing a variable x. So we can say x is greater than or equal to negative 4. The word here that is key is and. Okay, and so we can write the word and. X is less than 6. Now we said overlap. So when we overlap, we can actually make this into a compound, meaning two different inequalities, and we can put it into one phrase. Okay? And the way we do that is we put x in the middle, and we put our arrows just like this and this. Okay? So what is x smaller than? X is smaller than 6. Always put the bigger number on the right, just like you would on the number line. And then we're going to put the smaller number on the left. So 6 is bigger than x is bigger than 4. Where does the equal bar go? It has to go with the negative 4, so we put it there, and there's our answer. Again, the biggest number is going to be going on the right side over there, and the smaller number goes on the left side. And there we have a compound inequality. That's when we have the word and. Okay, what about the word or? What are the solutions? So let's go ahead and start. Wait, this is not the problem I want to start on. Pause. Unpause. Just kidding, let's do it. Okay. What are, number 2, the solutions of the following set? Graph the solution. So key word here is or. It means we're going to graph both graphs, and you're going to go in opposite directions. Okay? So first we have to solve this by solving for y, so we're going to subtract 7. So we're basically solving two inequalities. So negative 2y is less than negative 6. Okay, I like to put a line down the middle. Subtract 3 on both sides here. 4y is less than or equal to negative 8. Alright, switch the color up. Divide by negative 2. Divide by negative 2. And y is greater than 3. Notice I flipped the inequality because we divided by a negative, correct? Okay, so the inequality has flipped. Over here, divide by 4. and y is less than or equal to negative 2. Now this is an or statement, okay? So we start with the word or, okay? I like to put the bigger number on the right-hand side like we did before on the and problem. So y is greater than 3, or y is less than or equal to negative 2. When we graph this, you can literally just drop 0 right here in the middle, drop 3 here, drop negative 2 here, and y is going to go, we know it's an or problem, so they have to go away from each other. They can't go towards each other. They have to go away. Okay, so this is an open circle, and I'm going out that way. Y is bigger than 3, that makes sense. This is a closed circle, and y is less than. Or and an or. And overlaps. This is not an and problem, it's an or problem, so it shoots outward when we graph. Let's continue. Okay, problem number 3. What are the solutions of this graph? Now notice that it's already written in that and form, where it's all together as one. So we automatically know that this is an and problem, okay? Because it's written as one inequality. Normally, when we have one inequality, here we have 2 because it's a compound. When we have 1, I add to both sides. Well, now we have 3 different sides. If you think about it, I could draw a line here and a line here. So to get rid of this 4, I add 4, but whatever you do to one side, I said to do to the other side. In this case, we're going to do it to all 3 sides. So if it comes out in the middle, it's got to come out of the other 2 as well. So this cancels that out, so we get m less than, negative 1 plus 4 is 3, negative 3 plus 4 is going to be 1, and I'm going to rewrite it over here, but here is our inequality. Okay? Again, we know it's an and inequality because it's written as one. And they're together, right? Just like it's a statement that's together. Or they're 2 separate statements with the word or between them. Okay? Let's go ahead and graph this. What do you notice? The big number is always on the right, small number on the left. So we can literally just pull down this 3. 1's going to be over here. And open circle. This is going to be a closed circle. And we're going to graph in between them, okay? So if you want, you can just kind of draw a line connecting, and that's showing that their answer, our solutions, are anywhere in between that section, okay? Let's look at another one, shall we? Okay, let's do this last one. This is going to be an application problem, number 4. Make sure you write the problem out. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive, meaning we're including them. You score an 86, 85, and 80 on the first 3 tests of the grading period. What possible score can you earn on the 4th and final test to earn a B in the course? Okay, so this one's pretty tricky. All right, we need to score an 84 to an 86 overall, right? So somehow we gotta figure out how to do this, right? So I need an 84 as my low score. I can get up to an 86 between, must achieve between 84 and 86 to earn a B. Okay, so we're just looking at getting a B, right? If I went higher, I'd get higher than a B, but I'm trying to just get a B. So I have to get B in between. We're inclusive, so we're gonna include. Okay, so it's in between these. In between would be and. Do you see the key word here? And, right? We score an 86 plus 85 and 80 on 3 tests. What's the possible 4th and final test? Well, this is how averages work, right? You add up how many tests you have and you divide it by how many tests you took, right? So we took 1 test and we got an 86. We took another test, we got 85. We took a 3rd test, we got 80. Okay, we're going to take a 4th test, but I don't know what the value is, x. How many tests did I take? 4. Okay, from here we should be able to calculate what score we need to get on that 4th test to earn a B. Okay, so let's go ahead and try it out. First, how do I get a 4 out of the denominator? Well, to get a 4 out of the denominator, I'm going to multiply by 4, and it will cancel it out. Whatever I do to one side, I have to do to all 3 sides. So I'm going to multiply this by 4, and I'm going to multiply this by 4. And I'm going to bust out my trusty rusty calculator, and 84 times 4 is 336. The signs don't change. 86 times 4 is 344. And there we go. Next, I should probably add these three numbers together. So 86, oh, the lights went out on me. 85 plus 80. I'm going to try and get it back on. Hold on 1 second. Haha, they're back on. Okay, so I'm going to add up all of them. So I'm just adding the 3, and we get 251. So these 3 added is 251 plus x. Okay, to get x by itself, I need to go ahead and subtract 251 from both sides. Cancels. Whatever I do to one side, I have to what? You gotta do it to the other side. So okay. And let's go ahead and use our calculator. 336 minus 251. So I have to get an 85. And then let's go 344 minus 251, 93. So as long as I score between an 85 and a 93, I should be pretty good. Okay, I should have an average score between 84 and 86. Okay, that one's pretty tough. That was not an easy one. So we're going to get some more practice with and. So let's graph this real quick, where I'm going to have 85 and 93 inclusive. So we're going to circle these in, and they're going to graph towards each other or inward. So we can get any score in between there. This is an and problem. We're overlapping. We're heading inward. It's not an or. It's not going out. Okay? Salute. Hasta.